Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the latest episode of the Microchip Is podcast. Today, I'm learning more about the Power over Ethernet business unit of Microchip, and I'm talking to Jay Zwiren. Alan is a senior product marketing manager. Welcome to the podcast, Alan.
Thank you, Mike. Glad to be here.
So to start off with, Alan, can you just give me a bit of background about your role at Microchip and what you do?
Sure. I am responsible for the worldwide marketing for the Power over Ethernet business unit. That includes both making ICs, which put power on an Ethernet cable, and ICs that take power off an Ethernet cable. And we also make devices called midspans and even a couple of specialty switches that provide power over Ethernet.
That's great. I mean, a really good introduction. And I think most people have a concept of what Power over Ethernet is. It's you plug in an Ethernet cable and it powers a device. But can you explain a little bit more about the standards? I mean, are there different standards? How do they work? And who invented it?
So way back in the 1990s, at the time we were a company called Power Design, we were approached by some people who were doing IP phones and said, could you put power over an Ethernet line so that our phones would get power the same way that the telephone company phones get power? So we were the first to introduce on a commercial basis power over Ethernet. And that included creating the chips that put the power on the line and take the power off the line. Of course, way back in 1997, when we first came out with this, there were no power switches. So we had to invent a device called the midspan, sometimes also known as an injector, which comes after a switch that has no power, and it takes the Ethernet cable from that switch, it puts it into the midspan without power, and out the other end comes a cable that contains both data and power. And we introduced that, like I said, in 1997. We realized in order for there to be broad adoption of it, we had to establish standards. So we went to the IEEE. And I think it was in 2002, somewhere around there, we came out with the first standard. That was the IEEE 802.3 AF standard that could put up to 15.4 watts on an Ethernet cable at the source. And since that time, we have been involved in every standard. Today, there are standards that can put up to 90 watts of power onto an Ethernet cable.
Well, so, I mean, Microchip's been at the heart of Power Ethernet since its invention. I mean, that's really interesting. I mean, you talk about 90 watts as being, something that Power Ethernet's capable of. I mean, that sounds like, a reasonable amount of power. Is safety an issue with Power over Ethernet?
That's a great question. Anything under 100 watts, according to the National Electric Code in the United States, which is broadly adopted by most of the world, says that anything under 100 watts is considered safe power. So power over Ethernet is considered safe power. But on top of the power level, power over Ethernet requires that a device request the power, and it tells the source how much power to send. And then that source, once it classifies how much power is requested, starts sending that power down the line. But if there is any break whatsoever from either side, all power delivery will cease. So it's not only as a safe level, under 100 watts is considered class 2 power, by the way, but also if there's no request or if there is an error, PoE automatically turns off. So it is very, very safe power.
That sounds great. I mean, you talked about it starting off being for IP phones, which makes a lot of sense. But presumably now the new standards have opened up a whole range of new applications for Power over Ethernet. Can you talk a little bit about what are the main applications and maybe, some of the more interesting ones you see?
So some of the main applications today continue to be the IP phones, but it's not only IP phones anymore. It's the whole conference room. It's the video conferencing. It's the cameras in there. It's the displays in there. It's the speaker phones on top of the table that you see. All that can be powered by power over Ethernet. On top of that, security is a big issue. It started with cameras. And by the way, the added power can do much fancier cameras. They can do things called point, tilt, and zoom cameras that have motors in it, and even sensors that if it hears a sound, it will turn and focus on that sound. But it's not only the cameras anymore in the security, it's the security access points. It's the kiosks hooked up to the security to authenticate where you can go. It's even mundane things like the displays that tell you in a building which floor something is on. And then the last and major application is the wireless access point. Now, wireless access points provide wireless connection to the internet in most locations nowadays, and that is usually powered by power over Ethernet. Those are the biggies, but we are seeing with the added power just all sorts of new applications, powering PCs, powering laptops. You see it powering printers even. Under 100 watts is a lot of power to do some things with.
So that's incredible. So it's really expanded out from that sort of office communications into all sorts of different applications. Presumably, some of these applications bring additional requirements as well. I'm guessing, for example, the security, there's a lot of outdoor applications as well as indoor. Is that right?
Yeah, so there's two dimensions to what you're saying. The last standard that was written is called 802.3BT, and it was anticipating that power over Ethernet would move into the smart buildings realm. It's begun to do that, but there's a lot of ways to go. And one of the things that it can do there is power lighting. Well, in order to power the lighting, they added a lot of extra definitions to the standard to have instant on, to have instant off, to have power gradients to power up the lights or dim the lights. So there were a lot of requirements put into the new standards. But besides that, the applications have always been very diverse. Just take a look at cameras. You have indoor cameras, but the broadest growth in cameras nowadays is outdoor cameras. Those aren't the standard so much as those are go to the quality of the device that is powering it, the midspan. We build the midspans that are for indoor, but we also build highly secure, highly environmentally resistant midspans that you can deploy outdoors. We also have a very, very interesting outdoor switch, PoE switch, because outdoor applications are actually the fastest growing part of the market right now.
Wow, that's interesting. You covered a lot there. I mean, maybe we could just go back. You talked about midspans a couple of times. Can you just explain exactly what a midspan is, what it does?
Certainly. So a midspan, again, a device we invented right after inventing power over Ethernet, is very, very simple. If a switch does not have power, then you need to add or inject power on the line. So sometimes midspans are also called injectors. So you have a cable coming out of a switch, and that cable does not contain power. So then you put it into this device called a midspan or injector, and it goes through, it injects power onto the line that was containing data, and then it delivers it to the device. Now, nowadays there are plenty of power over Ethernet switches available. So you might wonder why people would still want midspans, but the simple fact is that 80% of the existing infrastructure installed today does not deliver power. So if all of a sudden you want to add a power application, you don't want to replace your whole network. You just want to build on top of your network and supplement that network. And that's where a midspan comes in. And even today, only 50% of the switches that are sold have power because they're more expensive. And a lot of times people will not buy power switches and then find out they have a power application afterwards. Even if you buy a power switch, there are limitations. There's something called the power budget. How much power is available to deliver on all the ports? Frequently, the power budget is not enough to deliver full power on all ports. So a midspan becomes important there also for the ports that cannot deliver power. If power is needed, a midspan can supplement those ports and add power to those ports.
That makes a lot of sense. I mean, I can see that. And certainly, even if you've deployed a switch with power, clearly the power budget means that you may still need midspan. So that really helpful to understand that. I mean, I'm interested because midspans are a device and Microchip really is known as a semiconductor company. So you obviously make midspans and you make chips. Do you make any other power over Ethernet products?
Yeah, so we have an entire line of power over Ethernet products. We have single port midspans for indoor. We also have single port midspans for outdoor. And we even have what's called single port midspans for industrial applications. Industrial applications might be on a work floor shop where there is added vibration, added electronic interference. Besides that, we have multi-port midspans that you can put right on top of where your switch is on a rack. So if you're adding power to, let's say, a building and you have an existing infrastructure, you just add that to your rack. You wire from the midspan to the switch, and then you take what was going into the switch, you plug it into the midspan, and you've powered up your whole building. But we also offer some other interesting devices. We noticed that there were no outdoor PoE switches. So in 2018, we came out with the first outdoor PoE switch. And since that time, just this past April, we've come out with the second generation of outdoor PoE switch. And it was basically built based upon the feedback that we got from all our customers. It contains 2 fiber ports so that you can daisy chain it. It is highly secure and it has complete remote management. So you never have to open the box once you put it on the pole. Actually, you never have to open up the box. So that's another security feature. We also make an indoor specialty switch for smart buildings and LED lighting. We also make a PoE to USB-C converter. We notice that many devices nowadays are being powered by USB-C. However, USB-C has a big limitation. USB-C cord can only run 3 meters, so that means it's tethered to a switch. But if you put one of these adapters at the end of 100 meters of PoE, then you can really place a USB-C device anywhere you want it.
That's quite an incredible range. And presumably you also make the chips as well, the chips to supply the power and also to use the power in the device end. I mean, can you tell me a little bit about those devices?
So we make 3 basic chips. One is called a power source equipment chip. This is a chip that goes into switches. Most of the major switch manufacturers are utilizing ours, and this will put power on top of an Ethernet line. We currently today have gone through 6 generations of these, and we're about to release our 7th generation. We have some very nice features. We put a lot on our chip, a lot more than our competitors do. So we have a much smaller footprint to deploy. We use a lot less power. So there are a lot of advantages to our power source equipment chip. Then the next chip that we make is called an ideal diode bridge. Now, an ideal diode bridge goes into a device being powered by power over Ethernet, and it's basically a rectifier. It makes sure that the power will not burn out anything in the device. The thing about our ideal diode bridge is that we don't use diodes. We actually use FETs. The result of using FETs instead of diodes basically means is we consume the least amount of power for that protective bridge so that most of the power can be dedicated to the device itself. And then we also make power device ICs. These are the ICs that go into the cameras and the wireless access points, and they take the power off of the Ethernet line and they put it into the device. But the most important thing they do is they request how much power is needed and send that request down the line to the power source equipment chip in the switch or midspan to tell them how much power is actually needed.
That's great. I mean, there's a lot of technology in there that's underpinning, some of the switches and the midspans as well. I mean, one thing you keep mentioning, and I'm interested to know, is outdoor devices. You keep talking about the fact you make dedicated outdoor devices. Is there a reason why people prefer these to simply taking an indoor device and putting it inside some sort of enclosure?
That is a great question. People are always price sensitive, and outdoor devices are, especially the way we build them very solidly, actually are more costly. Most people, to try to save costs at first, will take an indoor device and put it into an outdoor enclosure. These are commonly known as NEMA boxes. Well, what people don't realize is that a NEMA box can get up to twice as hot as the ambient temperature outdoors. The devices were never made to go to those heat extremes or the cold extremes for that matter as well. At very high heats, capacitors don't work, for example. So all of a sudden your unit fries out and it does not work. What we do is we build a device that dissipates the heat. Actually, the whole device is a heat sink itself. It's a sealed device so that nobody can go in and tamper with it. And it is rated to resist any environmental factors. So there are these industry ratings. IP66 means it can take a fire hose being pointed at it and it will still function. We actually make it to IP67 standards, which means it can be submerged for a period of time. So if you have a flood even coming through and it's not high enough on there, it will still continue to work. So we have a very, very important part of our portfolio that's dedicated to outdoors. And we try to explain to people why they need to invest in an outdoor device rather than putting it in an enclosure. Not only do we have the outdoor midspans, as I mentioned previously, we were the first to introduce an outdoor switch. We're on our second generation of outdoor switches, and those are extremely popular as well.
It makes a lot of sense, and I can see why it would be beneficial to actually use something that's designed for use outdoors. I'm interested, you must work with some of the other microchip divisions because clearly a lot of microchip products, I mean, not least the microcontroller families, need communications and need power. I mean, are you working with those other divisions, building reference designs and things like that?
So we have reference designs. I mean, the biggest collaboration is obviously with Ethernet switches.
Mhm.
And we work very, very closely with the microchip divisions that build that. Equally so that we work very closely with the divisions that put chips in things like cameras or wireless access points to be the powering units of that. So our power over Ethernet on the reference design side and on the implementation, we have something in Microchip we call total solution. And we try to make sure that we are providing all of the technology that is needed in a solution. And our POE division actually has one of the highest ratings for being included in total solutions. When we include a microchip IC, we are also generally including up to 4 other ICs from different divisions around microchip.
I love that. It sounds like Microchip's actually internally incentivizing different divisions to work together on these total solutions. Is that right?
So Microchip is one of the most interesting companies I have ever worked for. I worked for one of the largest technology companies in the world prior to this, and we were constantly fighting with others. The way that Microchip built its business from the ground up encourages everybody to work together. It's just an amazing, amazing environment. So there is no incentive to say, hey, if I make this sale, I get the commission and you don't get the commission. We are incented to work together to solve customer problems. We are incented to work together to build the best technology to solve customer problems. And it's a very gratifying place to work. I'll put it that way.
Oh, that sounds awesome. I love that. I'm interested to know with PoE, what do you see the future being? You mentioned building automation. Do you think that's going to be a big area where you're going to see growth in the use of PoE?
So there's a lot of things happening with electrification. Okay. I don't know how much of history you know about the wars between Nikola Tesla and Thomas Edison, but Thomas Edison thought that DC would be the future, and Nikola Tesla, which then became Westinghouse, thought that AC was. Well, AC won out. And the reason that AC won out was because you can't transmit power over long lines without tremendous drops for DC, but you can with AC. Well, once you get that AC power to a place where you're going to use it, let's say your house, let's say an office building, anywhere, most of the devices that are using that power are actually DC devices, except for things that have very large motors like washing machines, dryers, refrigerators. Everything else is DC. So what's happening is when you get to your device, I have a computer, a phone, and two screens in front of me. Each one has an AC to DC conversion. When you do that conversion 4 times locally, you have a power loss. Well, what's beginning to happen, and it just came out this year, is there is a new power. It's called Class 4 fault managed power. This is basically digitized DC power. It can run over intermediate distances, not long line distances, but it can run throughout an entire building without much power loss. And then at the end of the line, it can be converted to DC power with very minimal loss because, in essence, it is DC power. And then that can be used. So, what's happening today is the AC lines are still delivering the power to the building. It's being converted once to this new Class 4 fault managed power. And then at the point where it needs to be consumed by a device, since devices are already enabled to power over Ethernet, it's being converted to power over Ethernet at the final device. And power over Ethernet is powering many of these units. It's interesting. There's a hotel. The first real big application of this was a hotel in Houston called the Sinclair Hotel. And they were even redesigning things like irons. You know, irons need a lot of power, but it sits in the stand all day long. So instead of trying to make PoE power that, and there's not enough power to do that, they rebuilt the iron to have a huge battery in it. PoE would charge up the battery all day. And then when you take it off the stand, you iron whatever you need, you put it back on the stand for the rest of the day, and it recharges it. So there's even a reevaluation and a redesign going on in devices to look at how to become more efficient. And if you look at the power demand is growing. If you look at the power infrastructure, California wants everybody to have electric cars. There's not enough power in the power grid for everybody to have electric cars. So we have to start getting much more efficient with power usage. And PoE is definitely a key component in that movement as we go into the future.
Well, that's amazing. That's really exciting. I mean, it's come a long way from powering a few phones on people's desks, hasn't it?
Oh, definitely, definitely.
So as we wrap up here now, Alan, I'm really interested. Is there one thing you'd like listeners to take away and remember about Microchip's Power over Ethernet products?
Yeah, I will put it to you this way. If you are a manufacturer and you are manufacturing a device and you want to offer a powering option with that, Microchip has the right device to power it. On the other side of it, we're kind of unique because we don't only work with manufacturers, we also work with the people who install these devices. And if you want to install a power over Ethernet into a building, again, we have the right device. So it all comes out to having the right device for the right situation because one size does not fit all. So our portfolio is extremely broad and it offers the right solution for every need.
That's a great thing to remember. Another thing we're asking is, all the guests on the podcast, if they can help engineers and give them something that they can actually proactively do. So do you have some engineering advice you could give the listeners that will help them, perhaps improve their next design?
So if you are designing something, it is very, very important to understand, number one, how much power is needed. Number two, what is the environment you're deploying to? And once you have those two down, we can point you in the right direction, either for our ICs or for our midspans and switches to get you the right solution for every situation.
That's great advice. Alan, it's been fascinating learning about Microchip and how it is so important and so fundamental in the world of power over Ethernet. I'm sure people might have questions. So if listeners would like to get in contact with you, what would be the best way to reach you?
So I am extremely active on LinkedIn. I have a number of articles on LinkedIn on these topics. Please reach out to me through LinkedIn. My name is Alan, ALAN, Jay Zwiren, ZWIREN, or for those of you in the US, ZWIREN. And you can find me there, connect with me, and I will be happy to provide you any information that you need.
That's very generous, Alan. And I know that, you've put a lot of content on LinkedIn as well. So if people are interested, it's a great place to go to learn even more about Microchip's power over Ethernet products. Alan, thank you so much for being a guest on the podcast. It's been brilliant.
Thank you.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.